Next example warm-up piece that we're going to take a look at, we're going to use a tree diagram to determine the placement of 3 people in a photograph. Okay, so Anne, Bob, and Kathy are all posing for a group photo, and it's asking us to use a tree diagram to show the possible arrangements or seating combinations for these 3 particular people. So let's start off by identifying what the combinations are going to be. We know we have 3 options. We've got Anne, we've got Bob, and we've got Kathy. So let's say that we start off with Anne. Okay, and so if we start off with Anne, the first spot, okay, or rather the first spot, you could have either Anne, Bob, or Kathy. Okay, Anne, Bob, or Kathy. So in our second spot, if we have Anne in the first spot, then in our second spot we could have either Bob or Kathy. Okay, if in our first spot we have Bob, then in our second spot we would, let's just quickly connect those lines. If in our second spot we have Bob, then in our third spot, or sorry, in our second spot, we would have either Anne or Kathy. If in our first spot we have Kathy, in our second spot we could have either Anne or Bob. Okay? So if there's 3 people, there's 3 spots for them to sit. So that third seat, if we've got Anne and Bob, the third spot would then have to be Kathy. If we have Anne, Kathy, third spot would have to be Bob. Okay, and so forth. We've got Bob, Anne, Kathy, Bob, Kathy, Anne. Third set, we've got Kathy, Anne, Bob, Kathy, Bob, Anne. Okay, so when we take a look here, we actually have a grand total of 6 combinations. Okay, we got 1, 2, 3, 4, 5, 6 combinations. Okay, and so what we want to do is actually write out what those combinations are off on the side. So we've got A, B, C, A, C, B. We've got B, A, C, B, C, A. We've got C, A, B, or C, B, A. Okay, so those are our 6 combinations that are theoretically possible if we're going to organize this particular group shot. Okay, so we're going to use this tree diagram that we've created to answer parts A and B that are underneath here. Okay, so let's scroll up just a little bit here. So first part A here says calculate each probability using your tree diagram. Okay, so we've already created the tree diagram. We've already created kind of the master list of probabilities that's there. It's on the right-hand side. And so part A says calculate the probability that Anne is not standing between Bob and Kathy. Okay, that means the probability that Bob and Kathy are actually standing side by side. Okay, so let's figure that out, and we're going to identify this. That's going to be our, we're going to do this with a red line. Okay, so we're looking for a B and a C side by side. Okay, Anne cannot be in between. Okay, she can't be standing in the middle. So we're looking for situations where B and C are side by side. So here's one. B and C are side by side here. Anne's in the middle up there. So B and C are the same here, and B and C are together there. Okay, so for each of these probabilities, we want to determine what the probability is that Anne is not standing side by side. Okay, so in this instance, we have 4 out of 6. Okay, we know that there's 6 total probabilities. Okay, so we've got 4 out of 6 cases. We have Anne not in the middle. Okay, so let's reduce this to a fraction in lowest terms. Okay, so both 4 and 6 are both divisible by 2. So we're going to divide both the top and the bottom numbers by 2. So 2 out of every 3 combinations, we have Bob and Kathy standing together with Anne not in the middle. Okay, we can also extend that into a fraction, or into a decimal rather, which would be 0.66. Okay, and then we can also convert that into a percentage, which is going to be 66%. Okay, so let's take a look here for question B. What's the probability of Bob and Kathy standing beside each other? Okay, well, the probability of Kathy and Bob standing beside each other is actually the same. Okay, uh, the probability of Bob and Kathy standing beside each other is also going to be 4 times. Okay, if they're standing beside each other, it means that Anne is not in the middle. Okay, and so we have the same situation here. So 4 out of the 6 combinations, we have Bob and Kathy standing beside each other. That's the equivalent of 2/3 as a fraction in lowest terms, which is the same as 0.66. Okay, it's a terrible 6. I'll try and write that again. 0.66, which is the same as 66%. Okay, so as our second warm-up, that just kind of goes over again looking at tree diagrams and how we can use those to determine the theoretical probability of a given situation.